All right, so we're going to get started here. Again, thank you again for coming. Today we're going to be talking about a great product that you can find right here at Rhino Toolhouse. The product we're going to be talking about is GCI, and GCI makes smart arms and the software that goes with it called Adaptics. Now, behind me you can see we have a smart arm set up here in New Berlin, Wisconsin. After this presentation, should you feel the need to see one in live, a live demo of it, contact your local sales rep when we get beyond this coronavirus, and we should be able to bring you to our office and see the demonstration. This arm has 5 encoders on it. We can add up to 6 of them. There is, the one thing you won't see from Joel today is the one here. So there's an encoder here if you need to turn your tool. And the one thing I would note is today here in New Berlin, you see us using a desuder tool. The demo that Joel is going to do up in Bismarck, North Dakota is using a Clico tool. So the Adaptics program is tool neutral. We don't have a, it doesn't matter. We can use any one of them as long as it speaks open protocol. So these arms are great for bolt sequencing. So if you wanted to force your operator to torque, say, this bolt first, and then move to this one and follow a star pattern, that's what these arms are for. They are available right here again through Rhino Toolhouse. For this presentation, we're going to take you on a trip up to Bismarck, North Dakota, like I said. We would like you to do the following. So I need some help from you. So if you see your screen, at the top of it, you should see something that says View Options in the Zoom meeting. I want you to click on that, and in the drop-down, you'll see side-by-side mode. Click on that, and then you'll be able to see Joel's live feed as well as his computer screen. And then if you want to make his camera bigger, you can drag that side of the screen over. And lastly, actually not lastly, we want to hold Q&A like we've done before till the end of the show, so you can type them in at any time into the chat section, and we will address those questions at the end. And then finally here on tomorrow, Friday, we will be doing this again with a company called Extremity 3D. Extremity 3D is a great product. They are a custom design / printer, a 3D printing, and they've developed a lot of cool products for us, some standard, and then they'll do custom for you as well. With that, we're going to take you on the fastest flight ever up to Bismarck, North Dakota, where Joel tells me it's snowing today, so I'm glad you're not up there. But again, appreciate it, and you can contact your local sales rep with any question.
Guys, you got me muted. Hey, is everybody there? Okay, thanks, guys. Sorry about that. It looks like we're ready to go here. Yes, it's snowing in Bismarck, North Dakota today. So we're kind of locked in anyhow. So it would have been nice to be out with you guys over the last 3 weeks as opposed to sitting at home. My presentation is moving kind of slow this afternoon. So that's super awesome. So I want to kick off here real quick. GCI builds a lot of different types of products. We have torque reaction arms as well as material handling manipulators. In those products that we build, we even have customers that use manipulators as smart manipulators. So we can put products down in certain positions and follow along with it. All the programming and setup is going to be real similar as to what we're dealing with today. So we've been working at the Rhino tool house for quite a while, but for the last 3 weeks, I've been home with my coworkers here. This is Maddie, this is Dory. If they start barking in the background, you guys will know it. For the conversation today, I'm going to real quickly try to go through an introduction, a little bit of what we do, show some new products. I'm also going to invite you guys to reach out to your Rhino tool house rep so that we can come see you guys in person when all this being locked in at home is over. We're going to spend some time showing you how we program processes and what they do, and then we'll open it up to questions. If there are people that want to see advanced programming or calibration, we can figure out a plan for that from there. GCI was started in 1992. We work with most of the major companies that are out there. You may see your company on this list, but we got a lot of friends and a lot of references to fall back on. Of the products that we build on the material handling side, we're always looking for opportunities where you're lifting up a part that you need to do something with it. If you need to be able to turn it, tilt it, to cantilever inside of a work cell or something like that, we'd like to help. We have end of hook applications that can be mounted behind or below balancers and hoists. We have lift cylinders. We have our long reach carbon fiber arms that can be up to 20 feet in length. This particular system is called a stacker. And guys, I'm getting a note that my screen's not being shared. Wow, this is going really great. Do you guys have the screen now? Wow, okay, thanks guys. I'm used to doing this in person and being able to talk with you guys. So again, GCI works with most of the major manufacturers that are out there. The material handling manipulators, we can do things picking up like snowmobile hoods on an end of hook tool mounted below a balancer. Here we're picking up a part on a lift cylinder mounted on overhead gantry. My long work, my long reach carbon fiber arms are here. The stackers, which are designed to pick up really heavy parts. Vacuum lifts, even stackers mounted overhead to pick up 3,000 or 4,000 pound tractor tires. There's very little that GCI can't do or accomplish. In the torque reaction side of the business, we have end of hook tools. This one's a trombone tool that we can actually hold and capture the nut and the bolt while they torque it. The tool that we're going to use and work with today in my demonstration is a 100 Newton meter carbon fiber arm. It's designed to hold a tool that weighs about 10 pounds. The arm here on the right is a 7,500 Newton meter carbon fiber arm. And that tool has multiple axes for horizontal and vertical bolts. We do some cool things like tool carts, mobile platforms. We can even attach multiple arms to single pedestals to save floor space. So multi-spindles, you name it, we can make it happen. In the new applications that GCI has been releasing here, we're really proud of our new T50AS. It's a torque arm on a linear slide, mounted on the cable balancer. So it has a nice, even, smooth flow to it, can fold up out of its way and stay out of your operator's way. Again, the demonstration that we're using today, this particular arm is a 100 Newton meter carbon fiber arm. And finally, the T1000 lightweight version. This is now a complement to the IP5. So it has 1,000 Newton meters of torque reaction. At 10 feet in reach, this arm is about 380 pounds lighter than the previous version of that arm in steel. So it's a very inexpensive option for a very high torque reaction and a good reach. So pretty proud of the 3 new products. A lot of my friends at Rhino Toolhouse haven't even had a chance to see these yet. So moving into what we're doing next spring when we're all out of the house, I travel next spring with the carbon fiber arm. This arm that I bring around is a 1,500 Newton meter SmartArm. It's 12 feet long. I bring it in a trailer so that I can bring it right to your guys' facility and let your operators feel it, see how it moves, how it operates. So we'd be good to go. When you get a chance to talk with your Rhino reps, make sure that we get you on the list for the trip this summer whenever the travel restrictions let up. The project that I'm working with today, you guys, has a couple key components. I'm using my laptop as the industrial PC for my process guidance. I'm using the 100 Newton meter carbon fiber arm. The arm has on the back of it a module that my encoders plug into that also has some I/O capability. So I'm using the buttons on this arm for the OKs and the not OK signals, just as if it was a DC tool. The tool handle here, the drive of the tool tip is representing the tool, and I'm tracking this tool tip within about 1/4 of an inch in space. Finally, the last thing we have is the Cleco tool that Scott and the guys at Rhino Toolhouse have given me to use. It's a cordless right angle tool, and our conversation is going to go back and forth between my module as one tool and the Cleco system as the second. I'm going to minimize that and open up Adaptics. So guys, when we talk about the tool arm itself, one of the things that's really unique about the GCI arms is that I can use the arm in the right hand articulation or in the left hand articulation, and it'll know which bolt that it's on. Okay? As we bring the tool, I just got to notice that my screen sharing was paused. I think you've got my Adaptics screen here. So in that conversation, what I was trying to say is that with the arm, in the left-hand articulation, the crosshairs on the screen that you see right here are the arm knowing that it's on the right bolt to guide the operator through the sequence. And it knows if it's on that bolt in either articulation of the arm. So right now, the first step for this process is I have to get an OK on bolt number 1. And if I get an OK on bolt number 1, it forces me on to bolt number 2. If I get an OK on bolt number 2, it forces me on to bolt number 3. And if I get an OK on number 3, it forces me on to number 4. And if I come out of that zone, it'll stop. If I get a not OK, we'll know that as well, but it'll force me onto the next set of fasteners. Okay. Then I disable my tool, my SmartArm tool, and I enable the Cleco tool. So I'm hoping you can see the Cleco tool in the display there. The tool, now that it's pulled in the process, can run, and if I get an OK on its first piece set, it forces me on to do the rehit of the second bolt at a higher torque. And if I get an OK on that, that process is set to close, and it'll pull up the next process in that conversation. Okay? That next conversation that we have here, I'm going to take my vehicle and I'm going to move it well out of the range that I taught it for. And I'm also going to turn it. So in that, I'm going to have, the first thing I want to do is I want the operator to scan their badge number. Or maybe we want to scan the VIN number of your part or your vehicle. So I'm going to put in test one today for my barcode scan. I'm not connected to a scanner, so I'm using my keyboard as if it was the scanner. And if I get an OK on that scan, that the operator scans it correctly, now it wants me to tell my arm wants me to tell it where the part's at in relation to it. So I put the tool on bolt number 2, I squeeze the tool trigger, it knows where bolt number 2 is at. I move the arm to bolt number 1, squeeze the tool trigger, and I know where bolt number 1's at. Okay, now that I'm on bolt number 1, now I can start my running in my assembly process. So if I get an OK on number 1, it forces me on to number 2. And if I get an OK on 2, we're moving on to number 3. If I go out into number 4, you'll see that number 4 is flashing on your screen. Okay? And with that screen flashing, I'm locked by open protocol. The tool will not run. But I put it on the correct fastener. Those crosshairs is Adaptics sending the enable signal to the DC tool. And if I get an OK on the tool, we're off to the races. I get an OK on bolt number 4. And if I remember correctly, for bolt number 5 now, we're going to switch it to the PSET, to the application for the Cleco tool. And I'm going to run the bolt number 5 with the Cleco tool. That process is done and we're ready to pull up the next process. Okay? What I'd like to show you guys now, and the most important part of this conversation that we have, is we're going to make a new process. So in that process, I can make as many of these as you guys want to have. I'm going to click New. I need a graphic, a JPEG of your part from your operator's perspective, and I've saved on my desktop a folder for today's meeting called Demo Arm Pictures. So in my folder for my Demo Arm Pictures, I have a picture of the little white car, but this picture could be a model. It could be a screenshot of your part. What we want is something that really shows the process or the fasteners that the operator is installing in a nice clean picture. Just so you guys know, I'm getting a really weird echo through the computer, and it's making it a little harder for me to talk, but we're just going to push on through. So now that I've got my picture on the screen where I want it, the operator tells me what order I'm putting in the bolts. So I'm going to get my indicator icon, and wherever I touch the screen, I'm going to leave a dot. And to make it different from the previous projects we looked at, we're going to do a star pattern. And we're going to put 4 bolts on that with the star pattern. I'm going to get my stylus back so I don't leave dots all over the screen. Those indicators are kind of small and hard to see. So I'm going to highlight them. And instead of making those a 40 font, I'll make them like a 95. Nice and big. And those red indicators kind of blend into my part. So instead of making it red, we'll find a nice bright blue. We'll make it a royal blue. So we've got the indicators on to guide the operator as to where we're building. We're going to do 2 bolts with the SmartArm, and then we're going to do 2 bolts with the DC tool. Okay, so I'm going to take cylinders 1 and 2 and leave them, but I'm going to take cylinders 3 and 4 and erase them. Because we're just going to count on the operator to use the secondary tool. Maybe they're coming back and torquing hose clamps or something else with a transducer controlled click wrench. Okay, on cylinder number 1, I'm going to take the tool, put my vehicle in position in the station, put the tool on bolt number 1, and I'm going to right click. And when I right click, I can teach the reference. And when I did that, Adaptics just grabbed all of the encoder values for that position in space. Okay, I'm going to put it on bolt number 2. I'm going to look at my screen to make sure I'm getting the right bolt that I set up. Got to have a SmartArm for a dumb operator. And I'll teach bolt number 2. So I've taught it the references. Now I'll come down and I'll look at my tasks. The tasks are where, so I'm going to back up 1 second. In those cylinders, here's where I set the radius as to how tight those bolts have to be together. I can make that 1/2 inch. I can make it 2 inches, whatever. It all depends on how close those fasteners are together. Okay, so we'll make both of those 1/2 inch. Make it a little more difficult for me to do my test and let you guys see that. I can also increase the Z plus and the Z minus over the tops so that I can allow it to follow down a long fastener or run in there. Okay, so we've taught our cylinder positions. Now the operator is going to tell me what we're doing in this workstation. So task number 1, I'm telling it to blink indicator number 1, this dot right here on the screen. I'm telling it to run cylinder number 1, which is that position that we taught it to. And for bolts 1 and 2, I'm telling it to run simulator 1, which is my button pack over here on the side. For task number 3, we're going to tell it to run no cylinders because we're going to use a handheld tool. And I'm going to tell it to run my DC tool, controller number 1. Task number 4, I'm going to tell it, again, no region. And we're going to tell it to run controller number 1. But for controller number 1, we're going to make it change the application in the controller so that we run it to the higher torque angle. So we're going to tell that last fastener to run application number, we'll tell that one to run number 2. In task number 1, we'll put a beginning action in there. Parameter set select or application select. We'll tell it to run application number 1. And I'm going to save my changes. I'm going to call this process Rhino 3. I'm really clever with my naming nomenclature. And we'll save it. Funnest part of the job now is to see if Joel made a mistake in the demo. And because I've never had a chance to present to 100 people before, I'm guessing I'll make one. But we'll see. I'm going to click on Run. I'm going to find that Rhino number 3 that we made. And I didn't get any error codes. So that's encouraging. Right now, the Cleco tool is locked by Open Protocol. I can click the trigger, it doesn't run. I can hit the buttons on the arm, it doesn't run. But if I put the tool on the correct fastener, there's my enable signal. And if I get an OK on number 1, it forces me on to number 2. If I get a not OK on number 2, I can continue to hit it until you decide to stop or until I get my OK. Now, my tool's disabled, but the Cleco tool is enabled. And if I get an OK on the Cleco tool, for application number 1, we get an OK, and it forces me on to application number 2. And you'll hear the difference also at the higher speed and the faster torque. It is that easy to create new processes and set it up for your selections. Guys, that's kind of the overview that I wanted to show you today. I'd very much like to open it up now to questions to the group.
Joel, can you hear me?
There, I can hear you, Scott.
Awesome. All right, we're going to start with what do I do when bolts are close together?
It's a good question, and I'll go back and show on that process that we just created. If those bolts are really close together, I'm going to open that last process, that Rhino 3. I have an application for a medical device manufacturer that the bolts were about 1/4 inch apart from each other. So in that application, we had to have quarter inch tolerances really tightly. If the bolts are really far apart, we leave these tolerances bigger. But again, this is where I adjust the radius that I allow that tool to run within. So the arm itself, when it's calibrated, knows where the tool tips at within about 1/4 of an inch. So if the bolts are at least 1/2 inch apart, we can make this dimension now 0.25, and it will know that it's on that bolt without overlapping to the other one. Okay? If I make them too big, if I highlight both of those cylinders, and let's say I make those bolts 4-inch radiuses, you'll see this. When I put it on bolt number 1, if I get the radiuses too big, both radiuses are going to flash. And they're going to blink over the top of each other. So we have a lot of options there to make sure that the operator is on the right fastener, following the right sequence. What other questions can I help with?
Thanks, Joe. Next one we're going to do is, can this work with other MES systems?
Yes, it's a great question. In Adaptics, I'm going to close my running process. I'm not going to save those changes. Adaptics can pull in the configuration, the ability to add additional devices. Okay, we also have custom plugins to make this run passively with other MES systems. For the demonstration that I showed you guys today, I was the primary controller. But in that DC controller, we can go into passive mode, and I can run passively to whatever job, piece set, or configuration application that your controller selects. So if you're running in an MES system that wants to run 8 bolts of application number 1, your MES system can select it, and we'll automatically open up process number 1. We can follow along. If you need a custom configuration, we can do that as well. Does that make sense?
Sure does. Thank you, Joe.
You bet.
The next question we have, can the software be used with other applications besides torque applications?
Any device that has open protocol. So we integrate fairly commonly with cameras, Keon's or other brands, Cognex, other brands like that they want to use. We have pin stampers. We have fill stations. Again, we can add those devices right into that drop-down screen. As long as I have an open protocol communication that follows open protocol, we can make that work. And oftentimes there's no additional software or programming needed.
Great. All right. Next, from Robert, anything that outputs a digital never mind. Sorry, I thought that was a question.
Nope, it's all good.
From Colin, is there a cost associated with the software?
Yes. The software is part of the package when we sell an arm, but we also sell it as just process control, Adaptics process, and the process control includes the data collection. So in regards to other systems that are out there that are expensive, we're pretty darn reasonable.
Okay, next question. How do you deal with a continuous creeping assembly line?
It's always a challenge, and we're actually really proud of this conversation. The continuous moving lines. Let me see if I have a picture. Yep, I guess the right one. Can you guys see the picture? Did I share that correctly?
No, you didn't, Joe. We can't see the picture.
No, okay, I got it. There, I got it. We're really proud of this application, you guys. This is an application where GCI was able to use both material handling manipulators and a 16-foot carbon fiber arm. So this particular arm is running only vertical up, but we added a manipulator gripper that grabs the carrier of the vehicle and allows the whole arm to travel with the line simultaneously with the vehicle. So we know as they're tightening their axle bolts on the Mercedes vans, if they're on bolt number 1, 2, 3, 4, 5, or 6. Really a neat application. Again, we put the process over the top and allow the arm to travel with it. been a big success.
Okay, last question. Is the SmartArm technology offered on all your arms?
It is on all the arms that have made in the last 10 years or newer are all SmartArm ready, and you can order them either as a SmartArm or not. I'll be real frank, of the arm applications that we sell, about 10% are SmartArms. So, and then of those 90% that we sell, another 5 or 10% of those get retrofitted over the years, and we add the processes to it. What other questions might you have?
Okay, we'll hold it for about 30 seconds if there's anybody that has any final questions.
When I wasn't sharing the screen correctly at the beginning,
hold on, here we got one that just
anything that
came
I need
in
to recover?
from Brian. Other than data collection, is there a statistics package, or would the data need to be pulled out into a mini tab or Excel?
Currently, the package would be pulled out into a mini tab or Excel. And I have a lot of customers that are doing that to verify that they have all the okay rundowns on their processes anyhow. Again, it's a very straightforward, clean process without a lot of bells and whistles.
Okay, we had one new one come in. Can you modify a non-SmartArm that's already been put in the field to a SmartArm?
The GCI arms can be modified. The competitive arms that are out there typically don't have the machine surfaces or follow the same math that we need to have to make the process work. So the answer is yes, the GCI arms can be, the competitive arms probably can't.
Hey, Joel, can the data be uploaded to ToolNet, TorqueNet, or CVINet?
The data in those processes, those systems are grabbing the data simultaneously to the GCI data. I don't come between the path of that device and how DeviceNet or some of the others, or ToolsNet or some of the others are pulling it. If you want to have an automatic process on that, I could probably get together with our software team and try to help.
Okay, Joel, thank you very much. We are going to do switch back to our camera here in New Berlin and do a quick wrap up.
Thanks for everybody logging in, and sorry about the hassle at the beginning.
Hello again. Here we are back in New Berlin. What a ride we took today. So appreciate your time. And again, if you are interested in one of these SmartArms for bolt sequencing or the Adaptics package, not only for bolt sequencing, but also station level control, that can be found right here at Rhino Toolhouse. Tomorrow, as a reminder, Extremity 3D will be on, and that'll be a remote session as well from South Carolina. So appreciate it. And all the best to everybody that joined today. Thank you very much.